All right, I am going to share my screen with you. Boom. All right. So again, you all know that the class is applied math. You all have been here before, so you all have already enrolled in the class. So today we are talking about representing data. The objective is, again, to create graphic representations of data. So we're just creating graphs from a data set. Good morning. So our agenda, we are going to have our community meeting. We have a silly question for this one. We're going to do a warm up. And again, our warm up is going to be where we left off. Given one set of data, you will be, presenting it in as a box plot, a dot plot, and a histogram, but concentrating on the box plot and the dot and the histogram. Then we will review our lesson on box plots, and then we will move on to comparing representations. We will do a practice, and then the cool down. We will look at the cool down and discuss the cool down, which is due tomorrow. Okay. So, community meeting question. Like I said, it's a silly question. Who's your favorite entertainer? And you know, entertainer to me crosses music, sports, and acting, because all of them to me are entertainers. So of course, I put my girlfriend in my head, Gladys Knight, and on the throwback, Gladys Knight and the Pips. So that's my favorite entertainer. I know all her songs, old ones, new ones, ones that she had before I was born, when I was a little girl. I love Gladys Knight. So anybody else? Who's your favorite entertainer and why? And I like Gladys because she's timeless. She started singing in 1950s, 1960s, and she's still singing today in 2020. So who's your favorite entertainer?
Janet Jackson.
Oh, okay. Why Janet?
Cause she used to be like doing whole dances. I like that. Like when she performed and stuff. Hey, Pop Kill. She used to I like how she be like having real good choreography and stuff.
Yes.
It's like when she sang without no microphone and stuff, like just acoustic.
You right. Yeah, she's a true entertainer, like you said. She brings the whole thing. She can dance, she can sing, and she can act too. You right. She the whole package. That's cool. KML, Nas, who you got? And you don't have to just have one. You could it could be a tie between. Let me see if somebody chatting me, because you know you can always chat if you don't feel like talking. Who, me? No? No favorite entertainer? KML or Nas? Who else came? Because I got me.
I don't really know.
So, all right, if it's music, look in your playlist. Who's number one? Because I know you got an iPhone, and I just discovered the where they give you the top songs that you played all year. Who's the person you listen to the most from a music standpoint? Because that's probably one of your favorites. What you thinking? Oh, oh, hey, what's happening, Wells? How do? Nobody? Not today. We're not feeling the entertainer, just me and Hev. Okay. All right, well, if at some point it comes to your mind who is your favorite entertainer, then you could drop it in the chat. And again, like I said, this is just a silly question because our earlier question was a little more serious. And it's okay because we're going to balance our worlds. All right, so our warm up. Let's talk about data. So if you are given this data set, 3, 7, 19, 5, 11, 15, 21, 13, 17, 9, and asked to, I just want you to construct a histogram of this data and a box plot of the data. Okay, so remember that a histogram groups data into equally spaced bins, and it looks like a bar graph, but the difference is there are no spaces. It is continuous. And then remember, a box plot is a 5-number summary. So I am going to give you, let me look at my time. All right, so I have 9:40. So I'm gonna give you 10 minutes, and I want you all to really work on this. And then we will discuss what each one looks like. Remember, we will have lab this afternoon at 1 o'clock. So if you need some assistance, you are always welcome to come. I send a message to everybody. You do not have to stay the entire time. It's a pop-in. So you come, get what you need, and then you can leave. All right, we got about 4 more minutes. Oh, snap. I'm supposed to be sending it to. Dang, 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 dang. Oh, okay. Is he supposed to be in my class right now? Because if he is, I will call his father. Let me see today. Monday at 9. Yes, he is. Excuse me, you all. Good morning, Mr. Shears. My name is Lisa Hickson. I am Samaj's math teacher. And Samaj has not been to my class yet. I send an email every morning. I have him on Mondays and Thursdays at 9 o'clock for applied math. So I thank you for your concern. I am reaching out to you that you and I might work together to have him in class. So again, my name is Lisa Hickson. I am the math teacher. If you need to call me back, my phone number is area code 215-279-1688. Thanks again, and I hope to see Samaj in class. Take care now. I'm telling you, I just told on him. Uh-oh, who did I lose? Who did I lose? All right, I'm sorry. They're sending me text messages. I'm just responding. Get down, Daisy. You heard me. Thank you. All right, so ladies and gentlemen, here's what I expected to see. So now, in a histogram, it is easier to put the terms in numerical order, right? Now, I didn't do it there, but I did it in the bins. Because the data spreads from 3 to 21, I just figured the bins are going to be 5 units apart. So again, you see in your bins, now, you did not have to make your bins 5 units apart. But I would say to you, because the data only goes between 3 and 21, smaller bins may have been better than bigger bins. So if you made your bins 4 units apart, so you went from 3 to 7 and then 7 to 11, that's fine. But I would not have suggested that you do 10, like you went from 3 to 13, because then you would only have 2 bars. Good morning. You would only have 2 bars. So look at how you broke down your bins. Remember, a frequency table, which is what this is, a frequency table, helps you organize your data. So not only do you have the bins, but you see the terms that are in the bin. And remember, the low end goes in the current bin. The high end goes in the next bin. So you see that 13 went in the bin from 13 to 18 versus it going in the bin from 8 to 13. Okay? So again, these are the terms that you would be counting in each of the bins, and the bins are merely groups. It's just a way for you to group the data. And that's the frequency table, if you did it that way. Now remember, again, I said my bins were 5 units apart. If your bins were smaller, then you may have more than 4 bars. But I want you to get the gist of what is happening. And if you are a person who didn't quite understand, I would suggest you put this little sketch, including the frequency table, into your notes. Because remember, your notes will act as your notebook. So when you have to go back and refer to something, you will have it right there at your fingertips. Okay, we okay with the histogram? Can I move to the next slide? Okay.
Yeah.
Okay. Now, the dot plot, I wasn't stressing the dot plot because we don't have any repetition. The dot plot just looks like a straight line. So, and we're not going to really do a lot of comparisons with dot plots. Most of them are going to be histogram to box plot. So, without further ado, oh, I went backwards, sorry. Here is the box plot. So now remember, because we are looking for one of the measures of center, again, it is always good you put the data in numerical order from the beginning. I don't care what kind of graph you're doing, okay? It'll just make your life a little easier. So now remember, the first step in a box plot is to put the data in numerical order. And then in steps 2 through 5, you will find the 5 numbers that will be included in your box plot. So you identify the minimum value, you identify the maximum value. That's 2 of the 5. Then you find the median of the data set. Okay? Now, what you should have found was this data set has 10 terms. So when a data set has an even amount of terms, how do we find the median? When we count here, we got 5 here, and we have 5 over here. So there is no term that sits physically in the middle. So how do we determine what the median is? And again, your median should have been 12. Anybody? Okay. All right. So, ladies and gentlemen, if the terms of the data set are even number, in this case, there are 10, you still go to the middle of the data. So you came in 5 from the left, 5 from the right. So you have 11 and 13 in the middle. So 11 plus 13 is 24. 24 divided by 2 is 12. So you would have to, in essence, put an arrow, because now that is where 12 is. 12 is not a member of the data set. 12 is not a member of the data set. However, because 12 is the median, you need to indicate that 12 is the median, because now look at the data. It's split 5 and 5. Okay? So on your papers, again, first line should be the data in numerical order. But here, on your paper, you need to put a little arrow and put 12 as the median, because if you do not, you will probably not get Q1, which is the median of the lower half of the data, or Q3, which is the median of the upper half of the data, because you didn't put in the median. Okay, so again, first line should be your data set in numerical order. And I would ask that you put an arrow or some indication that shows that the median is 12, even though 12 is not a member of the data set. Okay, and again, we added the fifth term coming from the left and coming from the right, we got 24, and we found their average. So their average is 12. Now, we have for Q1, we are finding the median of the lower half of the data. So we are only looking at 3, 5, 7, 9, and 11. So we have a term that sits physically in the middle, 7. And for Q3, we are looking for the median of the upper portion of the data, 13, 15, 17, 19, 21. But 17 sits physically in the middle. And that's what your box plot should have looked like. If it does not, please make the adjustments. Anybody still need me to stay on box plot? You need me to add something to the slide. Would it, oh, excuse me. Would it help if for this median piece, it was 11 plus 13 divided by 2. Okay, so for anybody who needed clarity on how the median was found in the data. Okay, I added it there under number 3. And so remember, from the dot plot, from the box plot, what this shows is, first of all, 12, which is the median of the data set, is 5 units away from the middle of the lower, the middle in from the middle of the lower end of the data, and it is 5 away from the middle of the middle of the upper portion of the data. So that's why I called myself, or this should be like, this is split in half, because the median of the data set is 5 units away from the middle of the lower half of the data. It is also 5 units away from the middle of the upper portion of the data. Okay, and we see that the distance between the smallest value and the middle of the lower end of the data is 4. And the middle of the upper end of the data and the maximum value of the data the distance is also 4. So the whiskers should kind of be about the same length also. So the way you plot your box plot matters, where you put your quartile marks. Okay, and remember these Q's stand for quartiles because the box plot is in 1, 2, 3, 4 parts, and we know 4 parts are called quarters. Okay? Anybody still need the box plot? Okay. So now, we see here 3 representations of the same set of data. And each plot, each graph has its strength. And I want you to write some of these things down, ladies and gentlemen. So the strength of a dot plot is that you see each term. So had we not had a data set, if you had a dot plot, you could create the data set. You would know exactly what it looked like. So for us, if we did not have the data set ahead of time, we would have known the data set is 3, 5, 7, 9, 11, 13, 15, 17, 19, 21. We see that it is clear. So that is the strength of a dot plot. The strength of a dot plot is you can see each term. You know exactly what is there. The strength of a box plot is it's a summary. So you don't necessarily need specifics like you get from a dot plot. Okay, you just need a summary. You just need to kind of sort of see where the data is. So from a box plot, you can clearly see the lowest value of strength, the highest value. You can tell where 50% of the data lies. 50% of the data lies in this box. Okay? So half of the data falls between 7 and 17. Okay? And when you find the distance between, Q3 and Q1, that's called the interquartile range, IQR. And we're going to talk about that a little more, but just keep that on the frontal lobe. But you can tell here that the range between the middle of the lower end and the middle of the upper end is 10, right? So you can tell the range of the data, maximum minus minimum. But you can also tell the range of the middles, we can call it, because we know the median is the middle. We can also find the range of the middles, and it would still be the high minus the low. Okay, so there is information that you can get, again, from the box plot because it is a summary. And then lastly, the strength of a histogram is one, it can handle large data. And it can handle large data because the data is broken down into equal groups. So we see here that we just know between 3 and 7, because remember 8 gets counted, in the second bar. We know that in our data set, between 3 and 7, we have 3 terms. Now, we don't know what those 3 terms are. We just know that there are 3 of them. Same thing in the second bar, between 8 and 12. We know that our data set has 2 terms, but in that range. Again, we don't know which 2 terms. We just know that there are 2. So again, the strength of a histogram is it can handle large data. But if we want to know about something specific, a histogram is not the graph. Because again, a histogram has grouped the data together. So you can't tell about individuals. The only graph that will help us speak about individual terms is a dot plot. Okay? Does it make sense? Maybe a little bit. Kind of. Okay, I told you all, you know, your silence means keep it coming. All right, okay. So now we are going to be making comparisons. So your second cool down, for anybody who didn't look at it, they give you a histogram and a box plot. And they want you to match the histograms to the box plot. Okay? So there are certain things that we need to look for in making the comparison and thus making the match. So we need to look at the shape of the distribution. Remember, we talked about the 3 shapes. If it's symmetrical, it's skewed left or skewed right. We look for the maximum and minimum terms. Because a box plot, the box is made up of medians, we would then have to look at the histogram and kind of estimate where the median would be, because again, we are trying to match. And then we look for outliers. And remember, outliers are just those things that lie outside the bulk of the data. Okay, so let's look at the histogram first. So when we look at the histogram, we see that, okay. When we look at the histogram, we see that, number one, looking across the bottom, does anybody know what increments they're moving in? In years? They mark 5, 10, and 15. But what are the lines that they didn't mark?
I'm confused.
Oh, okay. So this, we looking at this, just the histogram, right? Mm-hmm. So when we look across this bottom, right? Because we are trying to see how this.
Oh, they didn't mark like no other number, like the numbers in between.
Exactly. Yes. So, yeah. And then when they did make a mark, this one is in between. But, when we would have to know that these are moving by 2s, 2, 4, 6. So 5 is in between 4 and 6, 8, 10. Okay, so now we know if we had a group of box plots that this is the one we want because this is moving by 2s. Okay?
Okay.
All right, so now here we see the minimum is 0 and the maximum that is connected is 12. So look at this graph. This line, the minimum on the box plot is 0. The maximum is 12. Okay? So That's our first comparison, because we don't really know anything about the shape yet, but we can look for the maximum and the minimum. So the maximum here is 0. That's where the graph starts. The maximum here is 0. When we look at the data that is connected, the maximum value is 12, because remember, they counted by 2s. 2, 4, 6, 8, 10, 12. So here, our maximum value is 12. So now, then it says estimate the median. So here, they're telling us the median is between 2 and 4. So we are going to assume from the box plot, the median of the data set is at 3. So now, let's look at the histogram. So between 0 and 2, we have 40. The median does what to the data? It breaks it into what?
I don't know, but I'm still participating.
Okay. So wait a minute. When we look for the median always falls where in the data?
In the middle.
In the middle. So
it's divided.
So when we cut that graph in the middle, how much we got on the left side and how much we got on the right side? If we cut it in the middle,
you gonna have
you got $1 and you got to split it with your sister down the middle. How much everybody?
You gonna get 2 quarters and she gonna have 2.
That's right. So that's 50 cents, right?
Yeah.
All right. So remember, ladies and gentlemen, the median splits the data in half, meaning 50% is on one side and 50% is on the other. The two sides may not look alike. So don't think that the median only splits it down the middle symmetrically, meaning left side looks like right side. Okay? Because the median just means 50% is on one side of the value and 50% is on the other. Okay? So when we look at this graph, right here, we already got 40. In this next bar, we got 28, but we only need to get the 50. So we got 40 here. How much we gonna need out this second bar to get to our 50?
10.
10. So see how this happens at 3? Look at this. 0, 2. So 10, that's almost like we cutting this in half, right? So that means it would be at 3. And here, the median is at 3. Did that make sense?
Yes.
Okay. Ladies and gentlemen, did you see that? Remember, when you are estimating the median, when you look at the box plot, it is there because that is your Q2 value. But when you are looking at the histogram, you are trying, they usually have either numbers or percents up here. You want to get to 50. So here we have 40. That means in this second bar, we only need 10 to be at our 50%. So it would be between 2 and 4. So that's how we got 3. So now we got 3 things. We got the minimums to match, 0 here, 0 here. We got the maximums to match, 12 here, 12 there. We figured out the median. The median here is 3, and we know that our median is going to fall in this second bar because our first bar gave us 40. We need 10 out of this second bar to get to our 50. So our medians match, and then we look for outliers. anything that is separated from the bulk of the data. So here, because all the data is over here. So we have these three things sitting out here, and you see this dot out here? That represents the outlier. So that's how we can say that these two match. So then they told us the middle of the lower end is going to happen at 2, which makes sense. Because remember, we getting us a little bit of this. So if 50% is happening in between here, between 1 and 3, the middle has to be 2. So that gave us our Q1. And then between 3 and 12, we kind of fall in there with 7. Now, again, because we're going to split half of this. So all of this over here is considered the half, the other half, or the Q3 portion where we're looking. Okay? But we're going to, again, I know it sounds a little crazy, but we're going to get there. Same thing here. The minimum is 0. The maximum, they went up by 1,000. 1,000, I can't see. So they going up by 10,000. So 10,000, 20,000, 30,000, 40,000, 50,000, 60,000. Okay? So again, you see here are the outliers. All of the data is grouped here. You see the median, again, will be 50%. So if this is 25, this is about, I don't know, 18, let's say. This is about 12, so that's 30. I don't know what they would call this. 19. Maybe they calling this, I don't know. But together, these two will be half of the data. So this line is there. So these two together represent about 50% of the data. So there's the median. So the middle, again, of the lower end is about there. But for me, talking to you, the key to matching these two is look for the outliers. There are 3 outliers here. Look for the outliers. Okay, and then you see the rest of the data is grouped over here. So I want to show you all. Now I wanted you all to match these, but let's see. We don't have time. So I want you all to, because we ran out of time, good people. So I want you all to look at the cool down. Ooh. Look at the cool down. And I'm having lab today and tomorrow. Do what you can from just our little discussion and come to the lab and we can clear up any discrepancies, okay? As well as work on the